All right, the goal of this video is to provide an explanation on the binary search algorithm. We've got some notes here. We've got an array again that we're going to search in this array, and we're going to search in this example for the value 13. Okay, to help with this as well, the smaller numbers here are the index values, right? Position 0, 1, 2, 3, all the way up to 9. So the key to the binary search algorithm is, in comparison to the linear search, which just started at the beginning and just kept going, the binary search tries to be a little smarter and tries to check the middle value. And then based on the middle value, we'll kind of say, oh, you know what, I don't have to worry about the top half or the bottom half of the list. And it narrows down where it can search. And it does that, it keeps track of that using some variables. The first variable we'll use is a lower index. And that lower index gets initialized to 0, the first element in the array. Well, the index of the first element in the array, so 0. The upper index gets initialized to the last index, or the index of the last element in the array. So in this example, 9. Okay, which would just be the length of the array minus 1. Okay, so we initialize those lower index and upper index variables. And these lower index and upper index give me the area that I'm going to search for. So at the very beginning, of course, I'm going to search the entire array. And as we go through the process, you'll see that our search area gets smaller. Okay, so then I've got this middle index variable, which I'm going to calculate. So the way I do that is I take my lower index. It's basically the average of these. But we have to floor it. We round down. That's generally what we do, is we round down if we get a decimal number. So in this case here, right, my lower index is 0 and my upper index is 9. So I should do order of operations here. Right, so 0 plus 9 gives me 9 divided by 2, which is 4.5. So in this case, right, we need to floor that down to 4. So my middle index becomes 4. Okay, so middle index is pointing at this value at position 4. Okay, so use the lower index and upper index to calculate that. And now I can check. And either I found it, right? If this was 13, I'd say, hey, I'm done. Or I check, because the binary search needs sorted data, right? This array is sorted. Because it's sorted, I can say, well, the value I'm looking for is 13. That's higher than 8. So I can eliminate everything below that. And the way that we don't really eliminate it, but I don't have to worry about this stuff, right? I can ignore this. So the way we do that is we use our lower index and we say, well, my lower index isn't going to be here anymore. I'm going to set it to be 1 more than my middle index, right? So now I'm going to search between here and here, right? Because what I'm looking for is greater than 8. It allows me to say, hey, let's not worry about this stuff right here. Right, I'm going to ignore that, and I'm just going to search from here to here. Okay, cool. So we've updated this lower index. Now we start over again. So I'm going to calculate the middle index. This time the lower index is 5. Upper index is still 9. So then we get 14, right? 5 plus 9 is 14. Divided by 2 is 7. And when we floor 7, we get 7. So the middle index becomes 7. Great. So now again, I check. I say, okay, I've updated my middle index, right? I've calculated that. The value at 7 is 34. Well, that's too big, right? I'm looking for 13. That's too large. So I know that it must be below this. So to indicate that, I update my upper index to be 1 less than the middle index, right? I can ignore these values because they're all going to be higher because it's sorted data. And I can ignore these. Let's use that line again. Okay, I can ignore these, and I know I'm only searching between here and here. Okay, so let's do it again. Right, I've updated my upper index. Now let's calculate. So lower index is still 5. Upper index is now 6. So that's 11 divided by 2, which is 5.5. We floor that to 5. So the middle index becomes 5. And I say, hip, hip, hooray, that's 13. That's what I'm looking for. and the algorithm, or the function would return 5, saying the value of 13, I was searching for 13, it was found at position 5. Okay, so again, key thing here, it needs sorted data, right? I can't ignore these values unless I know that all of the values are greater than what I'm searching for, right? So it needs to be sorted. So it's a little bit of a disadvantage that it needs sorted data, but because it's sorted, it allows us to do things a little bit faster and not have to check every single number. Okay, let's look at one more example. I've got another page here. Same array, but this time I want to search for 4. So a little quicker this time. We initialize lower index to 0, upper index to here. And if we did our calculation, 0 plus 9, 4.5, floor that to 4. Okay, this time I'm looking for 4. Well, the value at my middle index is 8. 4 is less than that, so I can ignore all of these values, and I do that by setting my upper index to be 1 less than the middle index. So my search parameters are now here. Okay, and now we calculate the middle index again, so 0 plus 3, right? And again, order of operations, I need to add and then divide. So 3 divided by 2 is 1.5, and I floor that to 1. Okay, so my middle index becomes 1. So the value there is 2. I'm searching for 4, so 4 is greater than this value. So I can ignore everything less than that, and I would update my lower index to say, oh, it's got to be higher than this, so I've got to search between here and here. Okay, then I calculate my middle index again. This time I go 2 plus 3 is 5, so this is 2.5, so floor that to 2. So my middle index goes to here, which is the value 3. And again I say, well, hold on, I'm looking for 4, which is greater than this value. So I can eliminate everything less than this, and I would update my lower index to be middle index plus 1. Okay, so now this is a little weird, but that's okay. Lower index and upper index are the same thing. So we go 3 plus 3 is 6, is 3, so the middle index also becomes 3. And we say, well, hold on, okay, so I'm looking for 4, which is less than this, so I can eliminate this. And because it's less than that, I need to update my upper index to 1 less than the middle index. Oops, there it goes. And now I'm like, well, hold on, this is weird, right? What's going on? My lower index is no longer lower than my upper index. It was okay when they were equal to each other. That's fine. There was still that one value that we could search for. But as soon as this happens, right, as soon as my lower index is no longer less than or equal to my upper index, right, once they overlap like this, then we know that, you know what, I've exhausted all the possibilities. 4 is not in my list, and the function, the binary search function, would return -1. Okay. Anyway, so 2 examples there for you. The big thing here, right, is the binary search needs sorted data. And because it's sorted, we can eliminate, we can divide and conquer, right, and use these variables to keep track of what we're searching, the search area that we're looking for, and it gets smaller and smaller each time. Okay, that is the binary search. I hope that made sense. Take care and see you in the next video.